Okay, good evening, all of you. My screen is visible. Anybody?
Yes, sir.
Okay, thank you. We'll see today cross validation. This is the one of the important topic in machine learning as well, because so far we discussed in the previous classes and all training and testing data. Now what we'll do is we'll go for as a cross validation because some drawbacks also there in training and testing data. To overcome that, we'll see some more technique. It is a cross validation. This technique is validate the model efficiency by training it on a the subset of the input data and testing on a previously unseen subset of the input data. So here, this is one of the approach. Total data set. Anyhow, we are dividing. In that, what we'll do is in the input data, we'll take it as a one subset and then testing on previously unseen subset. So in that some portion we'll take it out and that we are going to test. So this is the approach technique to check how statistical model generalized a independent data set. So independent data set in the sense that is not in a normal training set. It will be separated and there from there onwards we are able to test that model. So in that always the need to test the stability of the model. Once the model is developed, we have to check their efficiency and all. In this training data set, it means based on only on the training data set, we cannot find our model through training data set. That means normally whatever training data set is there, we cannot fit our model on the training data set as well. So only training data set we cannot predict. That is the reason. For this purpose, we reserve particular sample of the data set which was not part of the training data set. So in the previous one of the slide I mentioned, this is the total data set. In this data set, maximum of portion will go for as a training. This is the training. And another one we call it as a testing. So in this process, what we'll do is in the training data itself, we'll take it some portion separately. We'll reserve this portion. That's what validation purpose. I already shown that small bar also. I will show again once. In this, the concept is uh, some particular sample. So in this sample, let us assume that it is not used for training purpose. This is the training portion. In the training data set itself, we take it as a sum of the portion which is not used for training. We can go for as a what we call it as a that purpose. So that is a validation purpose. We can use it. So that is only the reason we can make use of this purpose. Now we'll see that after that what we'll do is test our model uh, that the sample before deploying the model. So that means once the model is tested, uh, after testing that model, what we'll do is instead of directly deploying the model, I mean final version, what we'll do is we have to process under cross validation. So we'll see what is the cross validation, something different from the training testing split. Means, as of previous class, what we discussed is normally there is a total data set is there. In that data set, 80% is a training and 20% is a testing, or maybe 70% and 30% and so on. But what we can do is in the training data set, we are going to split some portion separately. That portion will not be used for training purpose. So only for validation purpose. The basic step of cross validation, we have some procedure on the reserve a subset of the data set as a validation set. As I mentioned, in a training set, we divide some portion for the validation set, provide the training to the model using the training data set. So that's what whatever the model is there, this we can able to the training the model using the training data set, as that is normal concept. Evaluate the model performance using the validation test. So where we'll get this validation? This validation set is from the training data set only, but that portion of the samples or instances that is not previously used for training purpose. It is only for validation set. If the model is performance is well with the validation set, then the performance, the further step is else. Otherwise, you have to find the issues. So this is the way we are able to process. Then for this process, we have some methods. There is a lot of methods are there. In general, one method will use k-fold cross validation. This is the one thing. Or in general, we have some more methods, that is a validation set approach, and leave p out cross validation, and leave one out cross validation, k-fold cross validation, then certified k-fold cross validation. These are the some of the methods we have. As so far, whatever I explained, that will give you this picture. What is the picture you can observe? This is what I shown in the previous slides also in the last times. There is a data set. In the data set, we are dividing two parts. One part is a training part, this one. Other part is a testing part. Again, in training part, when we go for a class cross validation, we divide again, and some portion only used for training, and small portion also you be reserved and for the validation purpose as usual, then the testing purpose. This is the splitting. In that, we'll see the methods for cross validation. In the methods, there is a 5 methods. We'll briefly we'll see one by one. All this unit is only to understand the machine learning basic information. From next unit onwards, like what you call it as supervisor learning is the next unit, then reduction methods, that is the fourth unit, and then applications is the fifth unit. That is what in the first unit we'll come across all the aspects, whatever the basic information is there, that we are going to discuss here. And then that is what in the cross validation, first of the method is validation set approach. The input data set into training set and the test or validation set in the validation set approach. In the validation set approach, we are dividing the sum of the portion is validation as well. Both the subsets are given 50 percentage of the data set. That is 50 percentage of the data set means we are dividing in that context. But it has one of the big disadvantage is that we are just using 50% data set to train our model, and model may miss out the capture important information of the data set. This is the problem normally, because the in the data only 50% if you train, then rest of the data there may be some more insights may available in the data. But as of the machine learning, if you not train that model properly, model may not predict accurately, because that model is missed the some insights of the data set. That is the problem while it is predicting the. That is what is mentioning here. If you only 50%, the other 50% may be some more important information may be there, the combination may be there, because it is all about the Prediction means what? Directly we cannot take it one input and one output concept. So lot of information we need to give for the many combinations. So if this one is this, then next one is this, and so on, then finally output is this. So like that, we have to give. If any one combination is missing, or some important combinations may be missed in that 50 percentage of the data, obviously, while it is going for the prediction, if you're not trained, the model may not be understand the unknown data if it is other set of the combinations. Like that, it is many combinations we have to pass to get as a accurate model. That is what the major disadvantage in the validation set approach. And then another approach is there, leave P out cross validation. This approach, the P data sets are left out of the training data. It means if there are total of n data points in the original input data set, from that n minus p data points will be used as a training data set, and p data points are the validation set. So this is the another approach. What we can do is, suppose the total data sets are n, let n may be 1000 or 2000 something. In that, what we'll do is, p data sets are left out of the training data. So some portion will take it as a out of the training data. It means if there are a n minus 1 is remaining. So that's what we can able to validate the set. This complete process is repeated for all the samples. So in that case, it is improved when compared to the validation set approach, and the average error is calculated to know the effectiveness of the model. So we'll repeat this process one by one set of combinations. When each time we'll get some error, and we'll find the what is the average error. Based on that average error, we can easily identify the model efficiency. In this, what is the disadvantage is computationally difficult for the large P. So if the P is taken out, no, if it is a large P, we are passing the every instant, that will give as a computational issues will be there. And another one is leave one cut, that is out cross validation. In this method, similar to the leave P out cross validation only, but instead of P, we need to take one data set out of training. So instead of grouping a group of data set, we'll take it as a we are splitting in that one data set as to out of the training. That means each learning set, only one data point is reserved, and the remaining data points used for training model. This process repeat for each data point. Now what we'll do is, I will show that chain link as well. We are splitting one data set, then remaining will pass it. Then next instant, we'll take it as another data set, then the remaining will pass to the training. Then third case, we'll take it out, then remaining, like that. If we do that, n samples, we get n different training sets. In that, whatever, if you take it out separately and rest is already trained, then again we'll take it one portion and rest will be already assigned. So this is the way we are doing that approach. This approach bias is minimal as of the data points are used. Process is executed for n times, and execution time is high, because in each splitting, one time we will take it some portion and remaining will test it, then next piece will take it out, the next total remaining will train. Like that, we are doing all the models set of data. So you have to take it out and you have to train, and this approach leads to high variance in the effectiveness of the model. As iterative check again one data point. Now you can see the k-fold cross validation. This is the one way, is a very best method, I can say. The k-fold cross validation approach is divides the input data set into k groups of the sample equal in size. This we call it as a folds. So equal in size we have to divide. And for each learning set, the prediction function is used K1 fold. The rest of the folds are used for the test set. And this very popular cross-validation approach is easy to understand. The output is less biased than other methods. The steps of cross-validation we'll see. Splitting the input data set into K groups. For each group, take one group as a reserve or test data, because it is a theory. Normally, once if you writing a program of Python, how we are sending the data to testing the model, I mean, training the model. For that, this mechanism you must remember, so that the sequence you have to write in a Python program while you are going. Anyhow, for your case, the programming part is not there at moment. But once if you understand from second unit onwards, I will explain the each algorithm process as well as the huge number of examples also. From that, you try to develop a, either you can use MATLAB code also. The lot of applications used MATLAB code, but in general, the Python is user friendly to write this data science algorithms or methods and all. This fit the model on the training set and evaluate the performance of the model using the test set. Now, let's take an example of five-fold cross-validation. Dataset is grouped into five folds. As I said, how many cases are there, that grouping has to done. And first iteration, the first fold is reserved. Like I said, no, there is a, if I divide five parts, and in that, first may be reserved, and we have to train the rest portion. So suppose if first is reserved and we have to train the rest of the portion. In that manner, we can see, and the second iteration, what we'll do, second fold is used for the test model, and the rest is used for training the model. This process will continue until the how many? Five folds. So here the first fold, in the case of first iteration, first fold is reserved, means it will not used for the testing, and the rest are used for the training. First fold is reserved for testing. Only the first fold is reserved for testing, and the rest are used for training. Similar fashion, when you go for second iteration, second fold is used for the testing, and the rest is used for training the model. So this way we have to do consequently. You can see the diagram, that easy to understand. What we'll do is, there is a data set with you. Let's assume that we have as a data set, because the problem is five-fold problem, five-fold cross validation problem, because here K is a 5. What I'm doing here, I'm dividing as a five groups. Let it be as a fold, in the sense this is some set of data and this is another set of data. So total data set, what we'll do is, we can able to split this five. After that, what we'll do, we reserve this fold one for training, the rest for used for the training the model. The rest are used to train the model. This will be reserved for the testing, and other will be training the model. Similarly, we can see after that. Now again, we'll take it as a second one is reserved, and rest will be going to be training. And similarly, this will be reserved, then rest will be like that. We can see the colors also indicated here. Testing set as well as the training set. So training set case, one is going to be as a reserved, then the rest is going to be testing. So this way we can able to do. Another one is the last one, k-fold cross validation only. Satisfied the k-fold validation. This technique is used similar to k-fold cross validation with some little changes only. This approach works on the satisfaction concept. It is a process of rearranging the data to ensure that each fold or group is a good representative of the complete data set. they deal with the bias, variance. It is one of the best approach. Understood with the example of housing prices, such that price of the some houses can be much higher than other houses. So that way we can easily identify this approach to tackle such situation. We can use this type of the validation, cross validation. Last one is the holdout method. The simplest cross validation technique among all. In this method, what we'll do is remove a subset of a training data and use it to get the prediction results by training it on the rest part of the data set. The error that occurs in this process tells how well our model will perform with the unknown data set. This is only the normally what we'll do is if unknown data set is passed, how well it is performed based on the we can say that model is efficiency or in that whether it is giving any error that will be prediction. This will be performed the simple to perform. It still faces the issues of high variance and it is also produces the misleading results sometimes. This also some drawback is there. Now we'll see. As of now, we already discussed in the last class training testing split. That is what on the last class we discussed. And now what we'll do is cross validation and this thing. So we'll see small comparison. What we did in the training, testing split. This is already you aware that you can do any of this ratio. Let it be 70, 30 or 80, 20 and so on and so forth, two parts, which are training set and test set. And the ratio, with this ratio, we can able to split it. It provides a high variance, which is one of the biggest disadvantage. So because when we come across in the previous also, there is a biasing is there and then high variance is there. If it is more bias, less variance, or more this thing, obviously that is opposite of that. So the training data, this is used to train the model, and the dependent variable is unknown. Whereas test data used to make the prediction from the model that already trained on the training data. This has some features as a training data, but not the part of that. But whereas we come to the cross validation, what it is doing to overcome the disadvantage of that splitting into groups, so the data set into groups of training and splitting and the averaging the results. It can useful if you want to optimize our model has been trained on the training data set for the best performance. Is more efficient as compared to the train or test splitting, as every observation is used for the training testing. This is what we can do is in the case of training as well as the testing splitting, there some portion is completely missed there, because suppose 20% is taken as a testing purpose. Even though we are mixed the data and we taken out the 20%, because a lot of approach is there how to split the data. It is not for top 70%. I mean, per data is taken as for training purpose and lower data is a testing purpose or vice versa like that. It is not this so, but we have to mix the data. It should not be one way. We can able to pick up that data instances. It has to consisting of all the data, so that we will do even though if you are doing, but some portion is completely missing uh, for the training case. 20% or 30% data is missing. Whereas here in the cross validation, what we'll do, we are grouping that, and each group is going to be reserved one group, and the rest will be trained like that. We are validating. So every portion, irrespective of the data, even the splitting may be equally. We are splitting k-fold. Let's consider it maybe 10 splitting or 1,000 splitting, whatever the data density of that. But we are, one by one, indirectly, we are training the complete data set so that it will not miss anything. Now, there is a limitation also there. In ideal condition, it provides the optimal output. For the inconsistent data, it may produce a drastic result. So, inconsistent data in the sense, that's what, if any data is not used for training, or some data, like I will tell the example, suppose for trading and all, the past 5 year data you may be trained, but you are going to predict present data, let us assume that. What it will be, in the past data, company credential, all these things may influence on that data, but present thing, the present situation may be vary. That is the reason, while we are going prediction accurately, it will not be. That's what the trading is doing. So this may, some drastic results may change. But one of the biggest disadvantage of cross validation is now, certainly of this type of data is in the machine learning. The predictive modeling data evolve over a period, due to which it may face the difference between the training data and validation data set. So if we create a model for the prediction of stock market, that's what I mentioned just now. In a stock market, we can see that if your data is trained of the previous 5 years data, because stock market may vary even 1 hour change also. That but realistic feature, what will happen the next 5 years, you want to drastical different may be there. But you want to predict after 10 years based on the past 5 years data, you want to predict after 10 years, that will lead some, difficult in the model correction, all these things. That is the major disadvantage of that prediction. Now, we'll go for the some application as well. This is used compared to the performance of the different prediction modeling methods. When you compare to that, this may be better one way, and it is a great scope in the medical research field. It is also used for the meta-analysis, is already being used by data scientists and field of medical statistics. That some of the application, and we'll go for overall machine learning application. If I call it as a machine learning application, it is a never ending. Huge applications may be there. In future also, while we are discussing some of the concept, we can easily incorporate that concept also as a one of the application. That's why, as of now, whatever brief introduction about the machine learning we discussed so far, that some points, highlighted points, will specify in the field of application. Now we can see that learning associations. So what is the learning association? Suppose retail, if we take it. In a retail supermarket, a supermarket, huge data may be available. Based on that data, the machine learning is taken as a basket analysis, let us assume that. Because the customers will go and they will take it some groceries or whatever. So the basket analysis, what we'll do is, which is finding association between the products brought by the customers. What is the association between here? Suppose if you buy one product, obviously it's paste and brush, let us assume that. So that type of analysis we can easily get it, so that the relevant items may place in the one place or something like that. Now we can see, if people buy X typical, let it be maybe X any product, let us assume that, and also buy Y. If there is a customer who buys the X and does not buy Y, or he or she, so is a potential of Y customer. So once we find such customers, we can target them for cross selling. So like that, if even that we can, everybody is experienced while you are doing something, purchasing on the Amazon or Flipkart and so on. So what we'll do, if we are searching for one product, the relevant products it will show in the end. Suppose even for books also, if you are searching for MATLAB books, let us assume that, or maybe machine learning books, and at the end, the relevance type of books also they will show you. Or otherwise, suppose you are searching even in the science directory and all, if you search one topic, let it be as a machine learning applications to electrical or something, one topic, let us assume that if you provide keyword, it will display you some sort of relevant journals, and in that one pop-up will be open there. There some more list will be provided. If we select one paper in that, in the similar manner, they may open some pop-up there. These are the some more relevant papers near to that searching. Or even if you Google Scholar, if you have the account, they will share you the relevant field researchers list. Then you can able to follow them and you can collaborate them like that. So such kind of things is happen because of this machine learning only. We can target more if we know the combination. Like you can see here the condition probability, probability of Y with X. So how much probability may be there if the product is purchased, the Y product is purchased relevant to X, or X is there with you, there is a chance of buying the product Y. Like that, we can see here, let us say, mm, calculate the P. What is the P here? Probability of chips with beer. So that is 70.7, let us assume that. So we can define the rule such a way that what is meaning the definition of this here? 70% of the customers who buy beer also buy a chips. So this is the one set of combination. So like I said, bread and butter. So there is a chance, major chance is there. If you buy the bread, maybe jam or a butter, something is relevant. 90% or 80% of the people may going to buy that. So this analysis, we call it as a associations. Then we can see another example, because these all we already come across, but later in it, there is a classification will be there, regression will be there, and then clustering will be there, association will be there. There will get lot of realistic problem solutions, all these things. But these are all comes under applications only. Another one is a classification. This classification, credit is the amount of money loaned by the financial institution. For example, a bank to be paid back with interest, generally in the installments. So normally we'll take a loan, some 10 lakhs or 20 lakhs something, and we'll pay the money in the EMI model. What it will do is, so bank must know this customer is a risky customer or is going to pay back or not. So that analysis he must know in advance with this much amount of loan. So how we can identify with past history of the data in a same bank, let us assume that the many customers are already there. They may have taken the loans as well. Then what they will take a data set, what is his salary, what is his type of house, what are the other income sources, what is his property is available, and what is the mode of is payment, and many combinations of the ratio. So loan to salary ratio, like that. So we'll take the data from that. That particular customer is a faulty customer or a prompt customer. So like that, they will get the data, and that data will train to the machine learning model. Now, if the new customer comes, if he enter his age, because age also very important in that, because he is going to retire or he is having still service, may get the promotions or may get the increment, so on and so forth. The data, age is one factor, and then gender may be required, and then what type of house he is having. Based on the house also, he can predict uh, whether is a capable person or a poor person or something. Like that, they will present customer comes. Now the data will enter to the model. And model will give you directly answer stating that is a risky customer or not. Something. So that kind of things is going to be classification. That what we know, the bank will make a profit and also not to inconvenience to the customer, because even if customer also asking more money, even if he is not capable to repayment of the EMI, that's why lot of banks, they will consider this percentage of your salary only will become as a EMI, should not be more than some point of value. The reason is, if you take more amount, he has to pay more EMI, but the remaining amount may not be fit for his day-to-day activities. Then some point of time he may not be pay the EMI. That is the reason what they will do is they will consider that amount or percentage of the income for the EMI purpose calculation and all. Then credit scoring, bank calculations, the risk given amount of credit and information about the customer, everything they will take it. The customer includes data. We may access to the relevant calculation purpose. You can see here name, income, saving, collateral. So sometimes they may ask you some collateral based on the industry or maybe accept a personal loan. Some loans they will ask you collateral, or your profit has to register to the bank, that we call it as a mortgage or something. And age, what is the age, past financial history, that what credit score and all is there, no, the CBIL or something. So in the based on that information, they will decide. Suppose this is the condition, if income is greater than so and so and saving is greater than so and so, then whether it is a low risk or else it is a high risk, that such kind of combinations will get it the model. Once the data is trained, this kind of combinations will generate the machine automatically, because of the data, the huge data training there. And then if you are passing what is his income, what is his saving, and so on and so forth, for because not only these two huge combinations you have to compare, and finally they will give you the result, that is a prediction. Now, like you can see here, some portion low risk and then high risk based on the income and saving. If you take it that, what will happen is, there is a data set where because all the model is not directly giving. So what we'll do is we have to give the existing data for training and testing purpose. Then only final deployment is going to be takes place. That's what the whatever banks is having. That is the reason all banks are already online. They have their data. They have the model of exchanging their information, and huge data will be available. Many combinations are there, and they will directly nowadays it will be identified whether is a fault or a low risky person or a high risky person, something like that. There is a instant with input values in the corresponding access, and sign indicate the class. For simplicity, only two customers attributes, income and saving in this, just for understanding purpose only, but reality is not for two. And based on that, we can able to classify, because the problem is I mentioned, no, we have to segregate classification problem, whether the group of people may be there, then we have to segregate the low risk people and then high risk people based on our input data. And we'll go for as another one is a regression problem. In this, car predict the price of our car. This also nowadays a lot of apps or all these things are there. Input are the car attributes, maybe brand, year, engine capacity, mileage, and other information that we believe affects the car worth. So based on this data only, suppose second-hand car, something like that. So when you go for buying as a second-hand car, so they will see the lot of information, and the now model is ready. You will feed that information, and you can able to get the what is the worth of car, how it is calculating. You can observe some of the apps, suppose even Amazon or Flipkart, one new product comes, same company, and the old mobile you are selling there itself, and you can able to buy. And while you are giving the information of the old mobile, they will ask you question one by one. What is the age of this mobile, model of this, and the purchasing date or something, any scratches are there or not, and you send me the image of that. So you that data they may ask you to enter, and once if you enter the data, immediately they will display you the this mobile cost is this much. Who will do this? Nobody is doing there manually. Only thing is the model is already developed because of the all existing information. And now if you keep on filling this old mobile information, automatically model will say you this is your price. Similar fashion, in the car case also, if you enter brand name, year of purchase, Indian capacity, how much mileage it is giving, and some more information if you added, then automatically it whatever it affects the car of work. Based on that information only, we can able to identify the car work. The output is price of the car. Such problems will be the output is a number of regression problems. Let X denotes the car attribute, Y be the price. That's what the final attribute or a target, you can say that. And X may not be one attribute. It consisting of huge type of data. Like these are all, it may comes under the X attributes. And we can collect the training data, and the machine learning program fits the function. So all the cases, you remember one thing, what it will do is it will create as a function, like the calculation, how we are, as I mentioned, no, if I pass the input data of the mobile, then it will give the output. Again, it is not a manual calculation. The model is created as a one function or fit function. There these are the sum of the attributes. If you enter these attributes based on that fit function, we are able to identify what is our output. Like in this case, we can see that there is a y is equal to wx plus w naught for the suitable value of w1 w naught. So y is going to be able to find. Now you can see this mileage and price, because it's just for example, many parameters may be there in this. The function is fitted function, and then mileage is taken as only the input attribute, but it is not one attribute actually. If you give one attribute, output is not accurate. So features that has to be used more number of features, and also more number of instances also we need to use, then only we can able to get it. Now we can see some more applications. In broadly speaking, we can observe that automatic language translation. So now it is a huge machine learning approach only. We can any language you can select, suppose English to Telugu, or Telugu to English, or Tamil, or many things, even Google translators. These are all applications are there. And medical diagnosis. This is huge application you can see, but some of the critical diseases and all, by seeing MRI scan also, people may not be identified whether he is having cancer or so and so, the major cases. What we will do is image processing there. So a lot of images we are deploying with respect to the parameters of output. Then if new scan comes, if you simply pass that image, then they can like eye diseases and all. Similarly, cancer diseases. So what type of stage and all. It is impossible directly by seeing some images, human cannot identify. But such kind of application, machine learning is able to identify that, diagnosed. Another one is the stock market trending. That is also very important, because how best it is, I already mentioned one of the example there. Online fraud detection, like credit card and all defaulter. So some fraud transaction may takes place sometimes. This also you can easily identify using the machine learning. Then personal assistant. So virtual personal assistant, this is also there if you interact like suppose Kia car and all. If you can able to talk with hello Kia something if you say, and if you ask something, what is the weather condition today, or you navigate to some college or something, some information if you ask, automatically that is possible to interact. That is there many of cars as well nowadays, like a mobile. You can ask Siri or something. Then obviously mobile Siri is going to respond many your questions. That is the reason we can say virtual personal assistant that is possible. And this is also one of the important email. Whether the email is a spam email or a normal genuine email, because many of spam mails will come. That is the Google. Once the mail comes, you can see without your notice sometimes a lot of mails is going to be as a spam mail, because we are not segregating this mail is inbox or this mail is go to spam or something. The Google itself, there is a model for them. Google Mail itself, they deployed one machine learning model that will segregate and it will divide this kind of mail is related to the spam mail. Like that. By default, there, based on the subject, based on the email, based on the document inside the what they wrote. So all these things is a features. So like based on that feature, they will decide or whether that mail is already previously you communicated or not. If you communicated once or twice or something, obviously that will not be become as a spam mail like that. So lot of input information from your data available past information that will decide whether it is a spam mail or a original mail like that. So self-driving cars. This is also nowadays lot of Tesla cars or something. There is a EV cars in that self-driving cars also there. Because it is all about machine learning. So if you say navigation, then based on the sensors, that in turn there is IoT also they may use, and the IoT sensors which will sense the picture and it will process like Chandrayaan 3. There is they used already in the machine learning approach and all. So that is decide the model itself whether we have to land here or not. If any disturbance is there, based on the image capture, and they will analyze the data and they can conclude it is the good place or not something. So that kind of applications, many applications, product recommendations, whether that also I told no, once if you buy one product and it will get the recommendations whether you want to buy this product or not, or it will give you the recommendation if you buy bread and it will show you the jam butter and so on, and probable options what the guy, or if you buy many number of times that combination will show you the obviously the set in the cart, it will be showing and you can able to add that. And these are the some of the product recommendation. The traffic predictions. This also we can predict like a lot of weather predictions and forecasting many cases. The price like energy consumption, like this kind of predictions also there, and speech recognition also there. Now the we can if you call like how it is indirectly like phones and all. If you say something, they're reacting means what it means. It is a speech recognition and image recognition are like the same thing. Mobile app and all or normal mobile. If you want to open the mobile lock, so nowadays either thumb it is old model. Now if you show the face, automatically the mobile is going to be open. That is nothing but the image recognition. So this is the lot of applications you have. You can able to do this machine learning application. This, if you want to write one or two sentences, put as a subheading, and you can explain this way. These are the some of the applications of a machine learning. Now it is the end of the first unit. Now we'll start the next class from the second unit onwards. It is more interesting because it is all theoretical orientation. But second unit onwards, you can able to work out some problems. Question may come. The lot of test data they may give, and they may ask you to give some more new data, and you have to predict. Suppose whether something, whether he is going to play tennis or not, or cricket or not, based on the data points they may give, the past data point. The data features showing some cases it is going to play, some cases not playing and going to play, like that. The outcome may be yes or no in that, and they may give you some set of combination. They may ask you to find the answer. Find the answer means whether he is going to play or not. Single question. So like that, or classification they may give, or regression, or decision tree, like that. Lot of problems are there in the realistic problem. That's why it is very interesting from next unit onwards. Before going to that next unit, I am requesting you to read once. I will share this PPT for your convenience, and after that you read once. It is not much remembering, just once if you go through the theory part line by line, that itself it will feed you in mind, because everything is realistic. All whatever I shown you, the application or maybe any kind, it will be near to our day-to-day life activity. That's why we can easily remember this all the terminology as well. Once if you know this terminology, it is easy for you in the next lesson. So now I will, some of you can remind me in the later point time if I'm not send this PPT. Otherwise, if you share, I have your mail IDs as well. Yeah, I will do one thing. I will share this PPT to all of your mail IDs later, tomorrow or some other day, and you can read once. And after that, I think you have to write one assignment after first, second unit. I will give you so that it is easy for you to predict some type of model. You can do some exercise, or you can do some programming as well if you interested in that realistic problem. And if you write a program and get the results, that you can submit as assignment. That is also good. And if you aware this, you try to write a paper with reference to existing papers as a literature papers if you see, and try to develop small kind of publication, or at least abstract. I think in the next month 18th in our institution is organizing a research day. Then what we'll do is we can able to explain some concepts there, like abstract if you do, and you can explain some you will get the certificate as well. So this is for your practice purpose. Later point of view, if you want to go any jobs related to machine learning and all, it is a time to, that's what it is, a new subject actually in your seniors and juniors and all. Seniors, past seniors, they don't have this subject. So we newly introduced a lot of many novel techniques. We introduced not only this subject, many subject we reformed, and as per the requirement of the jobs and all. And you try to learn the Python as well and apply this techniques using Python, and you can able to get the result. That is a one data science engineer. You will become as a data science engineer. Such type of application is there in this unit. Try to learn Python as well, or it is very easy if you know MATLAB. It is very quite simple, or you can use MATLAB directly. You can able to solve. That is also fine. Yeah, if you have any doubt, you can ask me. Otherwise, you can leave. So sorry for disturbance. Actually, what I have a lot of work today in the administrative work, meetings and all. That's the reason I'm unable to take the class afternoon session. That's the reason I conducted today. This time. Okay, if you have any doubt, you can ask me. Otherwise, you can leave. Thank you all.